Welcome to the next video segment on statistics for 10th standard. So in the first video lecture we had solved problems from the first exercise where we solved problems on mean and median, and now in this video session we shall talk about mode of group data. Right? So let us see what mode of group data actually means. So mode is that value among the observations which occurs most often. Now let's take an example here. Now here we find that the number of wickets taken by a batsman, which is 0, 1, 2, 3 up to 6, and we find that the number of matches. So it means that in one match a batsman has taken 0 wickets, in one match he has taken 1, in 3 matches he has taken 2 wickets, in 2 matches he has taken 3, and so on. Right? So what is the maximum batsman or the bowler here has taken 2 wickets in 3 matches? So this happens to be the one which occurs with maximum frequency. Right? So in maximum matches, that is in 3 matches, he has taken 2 wickets. So here the mode happens to be 2. Right? So we consider that value which occurs maximum number of times. So we find that in 3 matches he has taken 2 wickets, so therefore the mode is 2. So this is how we find the mode. Right? So now there may be a possibility that a given distribution may have, so it may happen that a given distribution may have the maximum value many times. Right? So I can have a possibility where in 3 matches he takes 2 wickets. I also can have a possibility where in 3 matches he has also taken 5 wickets. Right? So we have a case where I have 2 values. 3 matches he takes 2 wickets, and in another 3 matches he also takes 5. So in such a case, when you have more than one value having the same maximum frequency, so here in this case you have 2 values which have the same maximum frequency here, right? So here 3 matches, here he takes 2 wickets and 5 wickets, right? So in that case it becomes multi-mode. But for our study we only limit ourselves for single mode, right? So in a single mode we only have one value which occurs with maximum frequency, that is, I have the batsman or the bowler taking 2 wickets maximum number of times. So therefore so in a group frequency distribution it is not possible for us to find the mode value directly as we did here in the first example. So let's take this example where a survey was done. So let's consider this example where a survey was conducted on 20 houses, and then we had the number of families and the family size. So here in this example, a survey was conducted on 20 houses, and what was the result? The result was there were 7 families with a family size of 1 to 3. There were 8 families with each family members 3 to 5. There were 2 families where each family had 5 to 7 members living, and there were 2 families with 7 to 9, and 1 family of family size 9 to 11. Right? So this is a group frequency distribution, and we cannot find the mode value, and we cannot find the mode value by simply looking into the maximum frequency. Right? So here if we observe, we find that the maximum class frequency is 8, isn't it? Right? So we find that there are 8 families, and each family having a family size of 3 to 5. Okay? So therefore the mode class which corresponds to the maximum class frequency is 3 to 5. So the mode class is 3 to 5 which corresponds to the maximum frequency, and then the maximum class frequency itself is 8, and then we also consider a number of parameters. Now we find that the lower limit of the mode class is 3, so L is 3, and then what about the others? Now h happens to be the size of class interval. So this is the size of class interval, which is 5 minus 3 equal to 2. Right? So L happens to be the lower limit of the mode class. H happens to be the size of the class interval. And F1 happens to be the frequency of the modal class. What is the frequency of modal class? 8. F0 happens to be the frequency of the preceding class, which is 7. And F2 happens to be the frequency of the next class, which is 2 here. Right? So given a distribution like this, we need to find these parameters. Right? So what are the things which we need to find? We need to identify the maximum class frequency. Here it is 8. The mode class is 3 to 5. I need to find the lower limit of the mode class, which is L, which is 3. And also we need to find H, which is the size of the class interval. So subtract the maximum minus minimum, you'll get the size of the class interval. So next we find the size of the class interval by subtracting the maximum and the minimum value. So 5 minus 3 is 2. Next we find F1, F0 and F2. So what is F1? F1 itself is the frequency of the modal class. F0 is the frequency of the preceding class, and F2 happens to be the frequency of the succeeding class. So once we find all these values, we can find the mode very easily by using the expression. Now what is the expression for mode? The expression for mode is L plus, so what is L? L happens to be the lower limit of the given modal class, plus F1 minus F0 divided by 2F1 minus F0 minus F2, the whole thing into H value. Right? So now let us substitute all these values. The mode is equal to L, which is 3, the lower limit, plus F1 minus F0. F1 is the frequency of the modal class, which is 8, minus F0, which is 7. So 8 minus 7 divided by 2F1, 2 into 8 is 16, minus F0 is 7, minus F2 is 2, into H. So what is H? H happens to be the size of the class interval, which is 2. So we get 3 plus 8 minus 7 is 1, 16 minus 9, so I get 7 into 2. Right? So this is 3 plus 2 by 7. So what is 3 plus 2 by 7? This is 3 plus 2 by 7, which is 21 plus 2 by 7. Right? So you get 23 by 7 as the mode. So the value of 23 by 7 is 3.286. Right? So the value of mode is 3.286. So given a distribution like this, group frequency distribution, we can find the mode by using this expression. So we have to find the value of, so we need to find the mode by using this expression. So what are the parameters which we need to find? We first have to identify the maximum class frequency and of course the modal class. So once you identify this, I need to find L, which happens to be the lower limit of the class. And then F1 happens to be the maximum class frequency, F0 is the previous, and F2 happens to be the succeeding frequency, and then we also need to find H. H happens to be the size of the class, which is maximum minus minimum. So this value of H remains the same, isn't it? Okay, so 3 minus 1 is 2, 5 minus 3 is 2, and so on and so forth. Right? So I guess we have got a fair idea as to how we can calculate the mode for a group frequency distribution. Right? So having known the basics, in the next video segment we shall solve all the problems given in the second exercise of your textbook, where we would have to find the mode for all the problems for the group frequency distribution and also calculate the mean and compare both the values. Right? So the mode value which is calculated will not be the same as the mean value. So there will be a difference in a few cases. So we shall see how we can solve all the problems given in the second exercise of your textbook in the next video segment coming up very shortly. So do not forget to like, share and subscribe and press the bell icon to get notifications of further uploads, and thanks for watching.